I'm Chris Galusha. I'm with the OneLink project.
And I'm Noah Anderson, developer for OneLink project.
Yeah, thanks for coming here. So the sponsor of our project, the company, was the Cyber Physical Networking Lab here at UNL. They're over in the Shore Center, and they're with the School of Computing. And our stakeholders would be Mohammed Lunar, Michael Fay, Dr. Vuran, and Prasant Subedi. And then our team from left to right in that picture is Noah, Chase Prochnow, me, Chris Galusha, Jonah Burke, Alex Rechsteiner, and Guy Richard. And we'd also like to thank Brady Garvin and Melanie Kuglerite, our tribe lead and project manager. They definitely helped us out a lot on this project.
Okay, so the problem we were addressing with this project was that researchers wanted an easy interface for checking all of these issues listed under the no easy way to check the status of the radio. So they want to know if the radio is transmitting or receiving. They want to know if it's connected, powered on, and they would like to know if antennas were connected and functional. But for a lot of these issues, it's kind of difficult to do that, especially when your network is spanning a large area or is even like in a completely different part of the state, like the radio in Meade, Nebraska. So our opportunity was to build a web-based dashboard for displaying the locations of these radios, as well as reporting back on any of these issues, including if they're transmitting on a forbidden frequency band. So in order to do this, we needed to somehow collect radio health data and system data from the radios themselves, and we needed to get it to be broadcasted to our website. We wanted to have some form of persistency with these messages that were sent up to the website, so we had to set up a way to log them. Okay, so for our website, we had a web UI that shows radio health dashboard. We're able to request specific health checks be ran on certain radios periodically. Administrators are able to manage the radios, manage researchers allowed to use the website, manage the frequency bands that are allowed on specific radios, and view the health statuses. So for our health check script, this kind of lived on a server that is connected to each of the radios that it's serving. And it's able to be ran on any number of these servers. It'll listen for health check requests from AWS, and it'll initiate health checks on radios, returning the results using the MQTT protocol, which is provided by AWS IoT. So in order to actually get this information from the radio itself, we needed to develop a GNU Radio plugin that would be embedded into the experiments that researchers create in GNU Radio. And this will hijack the link between that experiment and the radio itself in order to figure out data such as your center frequencies, your bandwidth, your gain, stuff like that.
Yeah, so to talk a little bit about our architecture here. So our architecture is sort of divided into three parts. So on the left, towards the bottom here, we have an AWS EC2 instance that houses our website. And that has all sorts of things like the actual views that users are seeing when they navigate to the website, and the controllers that are handling the logic, the MQTT client that's making requests for radio health checks, and a scheduler that's periodically scheduling those requests for radio health checks. Then up at the top, we have our AWS cloud layer. That's where our MQTT messages are going through to make it to the radio network on the other side. And then we also have our database, our RDS database running up there in the cloud. And then those messages are intercepted by AWS CloudWatch so that we can get logs of all the messages that get sent for analysis later. And then on the right side, we have our radio network. And so this consists of one or more radio management servers. And each management server is delegated to one or more radios. And those management servers have a health check script that is listening for requests, and then it will schedule these health checks either through SSH or through the GNU Radio plugin, depending on what sort of information it's trying to get. And then it will broadcast the results back through AWS back to the website where you can view the results there. So it'll look a little bit at some of the web pages. This is the radio management page, one of the more important pages here. So on the left, there's a list of all the radios that are included in the display. On the right here, there is a map of all the radios that we have assigned to the management page, so that you can see like the green and the red icons with the up and down arrows. Each represent an individual radio. And you can see that the icon changes depending on the health of the radio. So if you look at an individual one by hovering over it, you can see information about it, like its name, its location, the IP, which is just for administrators, and then the general health status. And then if you were to look at an individual radio, you can see an example picture of what the radio might look like, a little bit more in-depth information here, and then a list of frequencies that that radio is allowed to broadcast on, as well as the map with just the one radio.
Okay, so CloudWatch, if you're familiar with it, is going to act as kind of a logger for all of the MQTT messages that get sent over AWS IoT. So this will have persistency for about 30 days, and it allows researchers to go back and see any unusual anomalies in maybe their frequency they're transmitting on, or this more system data. Okay, so for the health checks, we have a way of kind of viewing them in the website as well. And as you'll see, the status, which we'll go over in a second here, and then the actual message itself that gets sent over. And this will allow you to check most, if not all, the radios accessible through the administrative panel.
Yeah, and give you a good history of all of the logs. I think you can see that this particular radio has like 50,000 logs right there that you can look through if you so desired.
And this is our basically rules for your frequency band. So if your band, your center frequency doesn't really fall within any of these, the administrators of this website will be notified via email. And this will also be, you'll see it in the CloudWatch logs too. And then these are the health statuses themselves. The name in bold is what gets displayed on the map, but the value associated with these statuses is listed as the name below it. This allows you to just make small adjustments if you see fit.
Yeah, so to talk about the value and highlights of this project. So the value to us was that it was an end-to-end development process where we got to start with an idea, take that idea, the vision from the sponsor, and build an architecture around it for a proposed system, take the architecture and build some prototypes out of it, do some incremental improvements on the prototype, and finally end up with the final product. So that was a great experience of end-to-end development for us. And it was also multidisciplinary. We got to work with hardware in the radio experimenting side of things. And then we got to work with software for the full stack web development and the Python scripting. And then finally, we got to work with cloud technologies like AWS and IoT Core through MQTT. And we got to do some fun stuff with networking, a lot of SSH tunneling and things like that. So it was a really great experience, and we were able to deliver a product that will hopefully be useful to our sponsor in the end. Any questions? Yeah.
So I saw that you had that list of networking rules. I didn't catch which slide it was on.
The what?
One before this.
Frequency rules.
Yep.
So does that have a way to automatically add additional rules, or?
Not automatically. It's a manual.
Sorry, not automatically, but
yeah.
in the UI.
Yeah. So you can see a little button down here, create a new frequency. So say if you had a new frequency that radio was particularly licensed to broadcast on, you could create that rule and assign it specifically to that radio.
Thank you.
Any other questions?
think we have time for one more question if there is one.
All right. Well, thanks everyone for coming.